Good morning, my name is Kaushik from CSE third year. So, and my topic is about Bayesian belief networks with example. So, coming to the introduction, Bayesian belief networks is the key computer technology for dealing with probabilistic events and to solve a problem which has uncertainty. We can define a Bayesian network as a Bayesian network is a probabilistic graphical model which represents a set of variables and their conditional dependencies using a direct acyclic graph. It is also called a bias network, belief network, decision network, or Bayesian model. Bayesian networks are probabilistic because these networks are built from probability distribution and also use probability theory for prediction and anomaly detection. Real-world applications are probabilistic in nature, and to represent the relationship between multiple events, we need a Bayesian network. It can also be used in various tasks, including prediction, anomaly detection, diagnostics, automated insight, reducing time series prediction, and decision making under uncertainty. Bayesian network can be used for building models from data and expert opinions. It consists of two parts: directed acyclic graph and table of conditional probabilities. So the generalized form of Bayesian network is that it represents and solves decision problems under uncertain knowledge is known as an influence diagram. A Bayesian network graph is made of nodes and arcs. So as you can see, A, B, C, D. So these are the nodes, and the arrows pointing towards each other are the arcs. Each node corresponds to the random variables, and a variable can be continuous or discrete. Arc or directed arrows represent the causal relationship or conditional probabilities between two random variables. These directed links or arrows connect the pair of nodes in graph. These links are represent the one node directly influence the other node. If there is no directed link, that means nodes are independent with each other. In the above diagram, ABCD are random variables represented by the nodes of network graph. If we are considering node B, which is connected with the node A by a directed arrow, then node A is called parent of node B. Node C is independent of node A. Bayesian network has mainly two components: causal component, actual numbers. Each node in the Bayesian network has conditional probability distribution P of xi slash parent of xi, which determines the effect of parent on that node. Bayesian network is based on joint probability distribution and conditional probability. So consider the example one. So here Harry installed a new burglar alarm at his home to detect burglary. Alarm reliably responds at detecting a burglary, but also responds for minor earthquakes. Harry has two neighbors, David and Sophia, who have taken a responsibility to inform Harry at work when they hear the alarm. David always calls Harry when he hears the alarm, but sometimes he gets confused with the phone ringing and calls at that time too. On the other hand, Sophia likes to listen to high music, so sometimes she misses to hear the alarm. Here we would like to compute the probability of burglary alarm. So the problem is to calculate the probability that alarm has sounded, but there is neither burglary nor an earthquake occurred, and David and Sophia both called the Harry. Solution. The Bayesian network for the above problem is given below. The network structure is showing that burglary and earthquake is a parent node of the alarm and directly affecting the probability of alarms going off, but David and Sophia are depending on alarm probability. The network is representing that our assumption do not directly perceive the burglary and also do not notice the minor earthquake and other confirmed before calling. The conditional distribution for each node are given as conditional probability stable. Each row in the CPT must be summed to 1 because all entries in the table represent an exhaustive set of cases for the variable. So for the burglary to happen, it is 0.02 chance, and for the burglary that is false, it is 0.998. For the earthquake to happen, it is 0.001. For the earthquake, if the earthquake does not happen, the value is 0.999. So since we are relying only on the workers that have been informed to Harry, so here we can see the David calls and Sophia calls. So earthquake is true and Sophia is false. So it means 0.91, this chances. If it is false, then it is 0.01, same as Sophia. Let's take the observed probability for the burglary and earthquake component. If P of B is 2 is equal to 0.002, which is the probability of burglary. If it is false, it is 0.002, which is 0.998. If the earthquake is true, it is 0.001. If the earthquake is false, it is 0.999. You can provide the conditional probabilities as per the Billiard tables. So these are the tables uh, that have the information about conditional probability table for alarm A, and the conditional probability table for David if David calls, and the conditional probability table if Sophia calls. So here, after uh, using the values for the in the formula of joint distribution, we can write the problem statement in the form of probability distribution. So here the answer will be 0.00068045. Thank you.